Illustration of longest increasing subsequence. In the last lecture, we learned about longest increasing subsequence problem. We learned about the dynamic programming algorithm using which we can solve this problem. Here, we are going to discuss how exactly to fill the dynamic programming array so that you can solve this problem. We'll take an example and we'll see how each entry is getting filled in this array. This will give you a clear picture of how this algorithm is running. Okay, what did we learn in the last lecture? We learned that whenever you want to find longest increasing subsequence from a sequence, that is, if you have a sequence of numbers something like 9, 5, 21, 28, something like this, a sequence of numbers, and from this you want to find which is the longest sequence that is present in increasing order. If this is what you want to find, what are the steps to be followed? In the last lecture, we learned the steps. Let us just write down the steps here. Then we'll follow those steps in order to solve this. First step that we learned is to create a DP array. What do we do this? This is for the dynamic programming. We'll call a DP array. This will be of size n. N will be the size of this DP array. What does each entry in this DP array represent? Each entry, DP of I, this will represent the length of the longest increasing subsequence which is ending at index I. This is what any particular entry, DP of I, will represent. Once you understand this, the next question is, once you start this DP array, what should you do with this array? The first thing to be done is to initialize all the elements. How do you initialize? You will initialize all entries as ones. Why do you want all ones? Because each particular entry is a longest increasing subsequence in itself with a single element. That is why the size of longest increasing subsequence is 1 if you have only one element. What is the third step? The most important step that we learned? Here, for each element DP of I, in order to fill it, you have to compare with all the elements that are occurring before this. And what do you do there? For each element, you will compare whether DP of I is greater. If this is greater, what happens? You can add this and prepare a new longest increasing subsequence. This is the logic that we discussed. What do we do here? You will see, in case if let us say the value of the ith element, for each of the element you have to see this. That is, I'll write it down here so that it will be clear. For each element at index I, for each DP of I, what should you do? Not DP, let us say I'll call it S of I. So that sequence of I. I'm considering that whatever you got as input is called S. S is a sequence of numbers. It is stored in an array. This is the input that you are having. Using this input, what are you doing? For each element I, what do you have to do? You have to compare with all elements for which you have index j, which is lesser than I. For all the elements before I in the array, what should you do? If this condition satisfies, that is, the element at I is greater than the element j, then what can you do? You can increase the size of your longest increasing subsequence. So your DP of I, in this case your DP of I, this will be maximum of, what are the two options that we discussed? One is whatever is already present in DP of I, and the other one is 1 plus what is present in DP of j. This is what we discussed in last lecture. After this, so in case it is not greater, you don't have to do anything. Whatever is the value of DP of I, let it be there. Finally, what is the last step? The fourth step is, what do you want to do? The maximum value that is present in DP array. So in the DP array, whatever is the maximum value present in the DP array, that is your final longest increasing subsequence length. This is what we discussed. Let us take an example and see how this is actually done. We'll take an array, a sequence of numbers, and on that sequence of numbers, we'll apply this algorithm. Let us say your sequence is something like this. Sequences 23, then you have 10, then you have 10, then you have 57. After 57, let us say you have 40. I'm just taking a sequence of numbers. You can take any sequence. I just want to illustrate how this algorithm is working. 32, 39, 74 and 50. If this is the sequence, let us see how it works. I'll mark it as an array. This is your array. This is the sequence array that you received. What are we going to do? From this, we are going to find what is the length of longest increasing subsequence. Let the indices be 0, 1, 2, 3, 4, 5, 6 and 7. So there are a total of 8 elements. This is what you have. What do you have to do now? Let us apply this algorithm and see how it is working. What is the first step? First step is you have to initialize an array called DP. This is where you are going to store all your values. Initially, the value of each element should be 1. All ones is what you are initializing. Let us do this initialization. When you do this initialization, this is your DP array. I'll just draw it right below it so that you know corresponding to each of these elements, you have an entry in the DP array. Okay, this is your DP array. In your DP array, corresponding to each of these elements, you have an entry. What is the next thing to be done? Next thing, this is your DP array. Each of the element has to be initialized with 1. This is the next step. Once you initialize everything, you can start the algorithm. What do you do with the algorithm? For each element, what are you going to do? You will see all the elements which are before this. So for the first element, there is nothing before. You don't have to do anything. Let us go to the second element. I'll just put index 0, 1, 2, 3, 4, 5, 6 and 7. What will you do with the second element? For it, you should consider every single j which is lesser than I. For that j, what should you do? You should see whether dp of I is greater or 1 plus dp of j is greater. This is to be done only in case the value at I is greater than value at j. Let us consider for this, we are considering for this particular element, that is for value 10. What is the value here? The value of this element is 10. So for value 10, what are we going to do? We are going to see all the elements that are present before 10. Before 10, only 23 is present and 23 doesn't satisfy this condition. 23 is not lesser than 10. So because of that, you can't do anything here. Just keep it as it is. Let us move on to the next one. Index 2. In index 2, the value present is 57. 57 is the value present. I'm not talking about what is present in DP array. I'm talking about the value present in actual sequence that is provided. Okay. In the actual sequence that is provided to you, value is 57. What do? You start from the first one and you see what to do. That is whether 57 is greater than that element. First index, that is 0th index, you have value 23. 23 is lesser than 57. So it is a positive scenario. You will check this condition. The condition is passed. 57 is greater. What will you do now? You will update this value dp of I as what the maximum of whatever is already present. What is already present? 1 is already present. What is the other value? 1 plus dp of j. So dp of j here is for 23 it is 1. So it is 1 plus 1 which is 2. Which is larger? 1 is larger or 2 is larger? 2 is larger. So you will substitute this with 2. Let us go to the next element. For the next element, again you have 57 is greater than 10. So 10 is the element here. and 57 is greater than 10. What will you do now? Because 57 is greater than 10, again you will see whether whatever is already present in 57, that is 2 is greater, or 1 plus 1, again 2, which is greater, both are same. So nothing to be done, you will leave as it is. Let us move on to the next element. Next element is having value 40. What will you do here? For 40, you have to go through each index and see whether 40 is greater. As far as 23 is concerned, yes, 40 is greater. 40 is greater than 23. What will you do then? You will see whether what is already present at 40, that is at index 3, value 1 is present, is that greater or 1 plus whatever is present in 23, 1. So is this greater? 1 plus 1 is 2. This is greater. So what will you do? You will substitute this with 2. What is the next thing to be done? Next thing is consider the next element. It is 10. Again 40 is greater than 10. What can you do? Whatever is already present at 40, 2, is it greater, or 1 plus 1, is that greater? 1 plus 1 is also 2, so nothing to be done, both are equal. Next entry is 57. Is 40 greater than 57? No, it is not, so nothing to be done here. You are done with this element as well. Let us move on to the next element. This is having fourth index. It is having value 32. For 32, again start from the first element. Is 23 less than 32? That is 32 greater than 23? Yes, it is. What will you do? You will consider value at 32, which is 1, or should it be 1 plus the value at 23? 1 plus 1 is 2, which is greater. So what will you do? You will write 2 here. Next is, you will consider next element 10. The same case, 10 is less than 32. What will you do? The larger among what is already present at 32, which is 2, and 1 plus 1. So that is also 2. Nothing to be done here. Both are equal. Next element is 57. 57 is not greater than 32. 40 is also not greater than 32. So nothing to be done here. You are done with this element as well. Let us move on to the next one. Next one is fifth index, for which the value is 39. For 39, what is the scenario? Let us go to the first element. Is 23 less than 39? That is 39 greater than 23? Yes, it is. So what will you do? Greater among value present at 39, which is 1, or value present at 23. It is also 1. That is, so 1 plus 1. 1 plus value at 23. It will be 2. Here you will substitute it with 2. Next thing. Next is 10. What about 10? The situation is same. 10 is greater than 39. What will you do? Value already at 39, which is 2, or 1 plus 1. So 1 plus 1 is also 2. Nothing to be done. 57 is greater than 39. So you can't do anything with 57. Move on to the next one. 40 is also greater than 39. Move on to the next one. 39 is greater than 32. So this time again you can consider. Here you have value 2, and at 39 you have 2, which means you have to take greater among 2, which is present in 39, or 1 plus value present at 32. So this is 2. 1 plus 2 is 3. Here 3 is larger, so you will substitute this with 3. What happens next? This is also done. Next element is having value 74. With 74, you will do the same checks again. Is 74 greater than 23? Yes. So which is larger? 1 or 1 plus 1? 1 plus 1 is larger, so you will substitute 2 here. The same happens here as well. So I'm not doing anything. For 57, 57 is also lesser than 74. 74 is greater than 57. What will you do? Larger among what is present at 74, which is 2, or 1 plus what is present corresponding to 57. So that is also 2. So 1 plus 2 is 3. The greater among this is 3. You will substitute this with 3. What is the next step to be done? Next step is you will compare with 40. 74 greater than 40 is also right. Again you will get the same condition. 2 plus 1 is 3. It will be 3 only. Again it will be 2 plus 1 3 only. Let us move on to next one. This one is 39. 74 greater than 39? Yes, it is greater. What will you do? you'll check greater among value present at 74, which is 3, or 1 plus value present corresponding to 39. That is also 3. So 1 plus 3 is 4. 4 is greater than 3. What will you do? You will substitute this with 4. Let us move on to the last step. In the last step, you have value 50. What about 50? 50 is greater than 23. Yes, the condition is satisfied. You will update this to 2. I'm not explaining because you already know. After this 10, 50 is greater than 10. This will remain as 2. Then you will move on to the next one. 50 is greater. This will move on to 3. Then again 3, 3, 4. So here it will be updated to 4. So finally you have answer 4. This is your final solution. In case you want to reconstruct longest increasing subsequence, then I told you in the last lecture you have to have a previous array. An array similar to this, which is called previous. In that array, you have to keep track of all elements, and in that you should mention which is the previous element from which you reached here. Then only you can do a backtracking. Okay.